Okay, I started the class, but they said the ITG people said the class is not happening. So I'll start it again. Yeah, good afternoon all. There was a problem with the internet connection. I already took 10 minutes of class, more than that, but they said it's not working, so I'll start it again. Right. I'll skip this and then start from here. Okay. So coming to the classification, there are two types. I will go faster. Epidemiological study designs are divided into two types: experimental study, interventional study, or observational studies. In experimental studies, clinical trials, field trial, and community intervention trials are three types of studies. In observational studies, again there can be two types: analytical or descriptive. In analytical studies, there is case control study, cross-sectional study, and cohort study. And in descriptive studies, these are longitudinal studies, cross-sectional studies, or ecological studies. Now coming to the hierarchy of the scientific evidence, as I was telling earlier, but okay, so you start from the base. So if there is a new history, new disease, or new factors is discovered, or new disease come into play in the world, the first thing is case report starts coming up. The first thing is case reports. So there are case reports first, which come out, and then the second step there are case studies which are being explored. After case reports, on the basis of that, people start doing case studies, and after case studies, then there is a cross-sectional study. Cross-sectional study is the first study where we try to test the hypothesis, whatever is coming from case studies and case reports. And after that, then there is a testing of hypothesis further by cross-sectional view, observational, then case control, then cohort, then non-randomized control trial, and current and historical controls, non-randomized control trial, and then randomized control trial and meta-analysis. These randomized control trials and meta-analysis are the gold standard ways of finding out the association or a cause or exact information about any new disease or any risk factor for the disease. Now, cross-sectional study entail collection of the data, a cross-section of the population. It is a cross-section of the population. So we cross-sect the population and we cross-sect the time. So we freeze the time and then we see what is happening between this time. Now comparison of whole population or sample of whole population. It's a comparison of whole population or a sample of whole population. Now cross-sectional studies otherwise is called as prevalence studies also. Now prevalence rate is equal to number of prevailing cases of the disease, old or new, old and new, existing in the given point of time upon estimated population at the same point of time multiplied by 1000. Now observational now observational studies, the single examination of the population at one point of time is. So observation, when it come to observational study, it's a single examination of the population at one point of time in time. It is individual based. The measure exposure and effect, and exposure predicts the following effect which are not known. Okay. Now descriptive cross-sectional study or population community surveys or prevalence study. The information about single or multiple variable. So they give information about single or multiple variable. Then estimation of the problem like prevalence or like prevalence. Okay. So descriptive studies, what kind of information they give? They give information about single or multiple variables, or single or multiple risk factors, or estimate the problem like prevalence. The point. Now point prevalence and period prevalence. So prevalence can be estimated by point prevalence, period prevalence, or disease and suspected risk factors of the population of specific individuals. Now analytical cross-sectional study is the information is information which gathers is presence and strength of association and testing of hypothesis. By definition, an analytical investigation is in which subjects are sampled at a fixed point or period of time, and then the association between the concurrent presence or absence of risk factors and disease are investigated. Coming to descriptive cross-sectional studies, the presence of disease, disability, and symptoms of ill health. So descriptive cross-sectional studies can predict the presence of disease, disability, and symptoms of ill health, dimensions of positive health and such as fitness, and attributes related to health, body measurements, blood pressure, like blood pressures, and etc. Now, what does analytical cross-sectional study does? It measures the strength of association between disease and risk factor. It measures the strength of association between disease and risk factor. It determines the determinants of the disease and or conditions. Or third, it determines the predictors of the disease or condition. Now, attributes of cross-sectional studies are population studied comprise of survivors at a point or period of time Attrition may have occurred before the study and describes association between exposure and disease simultaneously. Okay. The attributes of cross-sectional studies are: the population studied comprised of survivors and point or period of time. Attritions may have occurred before the study, and it describes the association between exposure and disease simultaneously. It measures prevalence of the disease in exposed and unexposed. It measures risk measurements and prevalence ratio. Inexact estimate of relative risk or odds ratio. Evidence of causality is not only suggestive. The evidence of causality is only suggestive. It does not confirm the causality of any factor to any disease. The evidence of causality is only suggestive. Should be very clear about this. And more prone of selection bias. It is more prone for selection bias. Design of cross-sectional study. We take sample reference population, then we take out the sample out of that reference population. We do sampling, and then we do measurements and find out exposure or outcome, exposure or no outcome. Exposure and outcome. So there are different sets of exposure and outcome we can find out. We can find out characteristic and disease, or characteristic and no disease, no characteristic and disease, and no characteristics and no disease. It is just like 2 by 2 table in chi-square. So exposure and disease measured simultaneously, and as you see, the cross-sectional study a cross-sectional study is have a much wider horizon compared to cohort and cross-sectional study. Okay, steps in conducting cross-sectional studies. Now, state and criteria for the disease and the conditions is clear. Okay, state and criteria for the disease and condition is clearly defined. Define covariables to be measured. Examine ethical issues. Identify reference population. Then put inclusion and exclusion criteria. Determine minimum number of sample required. Select study subjects through appropriate sampling procedure. Define measurement procedures. Carry out data collection. Then do clinical examination. Make clinical records and documents. Interview and questionnaire. Conduct interview and questionnaire. Then summarize the data. analyze and interpret findings, and then report the findings. So these are the steps. I'll go through it again. State the criteria and criteria for the disease and conditions clearly. Then define core variables to be measured. Then examine ethical issues. Then identify the reference population. Then quote inclusion and exclusion criteria. Then determine minimum number of samples required. Select the study subjects through appropriate sampling procedure. Define measurement procedures. Carry out data collection. Then carry out clinical examination. Then clinical records and other documents. Interview and questionnaire. Introduce questionnaire. Then summarize data. Analyze and interpret findings, and then report the findings. Now coming to the analysis of the data in cross-sectional study is the descriptive cross-sectional study. If there is a descriptive cross-sectional study, that is measurement of the variables. For continuous variables, mean, median, standard deviation, and percentiles analyzed. Nominal data, prevalence of rates and proportions. And 95% confidence interval can also be calculated. Now, analytical cross-sectional studies, it can be done for continuous variables and correlation and regression of coefficient. Nominal, if there is a nominal data, then odds ratio, rate ratio, and exposure ratios can be calculated. And basic from the data construction. Basic from the data construction is analytical cross-sectional studies with nominal data. So it's a 2x2 table. A disease present or absent, and exposed, and the person exposed divided upon unexposed. Okay, we have discussed the formula in case control study. The formula remains the same. Okay, some common applications for cross-sectional study are in community health care. Some common applications for cross-sectional studies can be applied in community health care, in clinical practice and patients care, in program evaluation, and acquiring new knowledge. The biases in cross-sectional studies are choice of sampling frame, non-response. Okay. Biases in cross-sectional studies can be handled by choice of sampling frame, by controlling sampling frame. Then non-response information. So choice of sampling frame, if that is wrong, then it becomes a sampling bias. Response, non-response becomes an interviewer's bias. There is an information bias, observer's bias, and prevalence bias in hospital studies. Like hospital studies, when I say the bias is like if you want to understand the prevalence of some disease in the general population and you take hospital population as a standard population, then you choose the wrong sampling frame because the person who is coming to the hospital himself is a very sick person, mostly the sick person, and there are high chances that you will get high prevalence of any specific disease in hospital studies. So it is known as prevalence bias. Uh, Coming to advantages of cross-sectional studies are: it provides estimate for the disease burden. It's relatively short duration. It's easy and quick. It's less costly, and it's useful for chronic conditions with low case fatality. The starting point for cohort study for screening existing diseases are: starting point for cohort studies. It can serve, sorry, cross-sectional studies can serve as a starting point for screening existing diseases. It provides wealth of data for further research, and it allows risk statement, although these are not very precise. Now, coming to the disadvantages of cross-sectional studies: it does not provide estimate of disease occurrence, that is incidence. It does not provide estimate of a disease occurrence. There is no direct estimate of risk possible. There is no direct estimate of risk possible with cross-sectional study. A rare rare disease, short duration, and high case fatality is not detected. A rare disease, short duration, or high case fatality rates cannot be detected by cross-sectional studies. The natural history of the disease information is minimal. In terms of studying natural history of the disease, the information is very minimal. It is prone for various biases, from selective survival, and not possible to estimate temporarily. Temporality. Therefore, it is a weak design for providing causality. Some important methods in cross-sectional studies are rapid epidemiological assessment procedures like Simple, inexpensive, but it is simple, inexpensive, but adequate enough to provide estimates for programmatic decisions. It's useful in emergent situations for appraisals of health needs. For examples, it's a coverage evaluation survey like EPI, cataract survey by trained paramedical, and identification of low birth weight newborns by trained birth attendants using color coded weighing machines. Now, in a study to assess the prevalence of hypertension among adult male population, in a study to assess the prevalence of hypertension among male population, 1000 men above 30 years of age were examined. Now, detailed history about lifestyle issues were also collected from them, and the blood pressure were recorded as per the WHO guidelines. The hypertensives were identified as per GNC guidelines, and the data is presented as follows. So this is the example of cross-sectional study. Let's see what happens. So if you see, there is a 2 by 2 table here. Disease is hypertension. Either it is present or absent, or the risk factor, which is smoking, either it is present or not present. If you see in the people who are smokers, means smoking risk factor is present. The presence of the disease, which is hypertension, is 120 people had 120 people have hypertension who are smokers, and who are smokers, 280 people do not have hypertension. And in non-smokers only 30 people have hypertension, and 570 people do not have hypertension. So if you construct 2 by 2 table and see so this is the example A, B, C, D. If you see, the prevalence of hypertension among smokers will be A by A plus B, and prevalence of hypertension among non-smokers will be C by C plus D. So if you see, prevalence of hypertension among non-smokers is 0.05, and prevalence of hypertension among smokers are 0.3. Now further you go, the rate ratio is prevalence among exposed divided by prevalence among non-exposed. So the rate comes out to be 6.0, and odds ratio, if you calculate, comes out to be 8.14. You guys can do some examples, solved examples from internet. You will get it, and it will help you for biostatistical and epidemiological exercises as well in your exams. So just a minute. Okay. Now applications for different observational study designs are: okay, I'll skip this. Okay, so we finish this. We finish our study now, and thank you. We'll discuss some other. We'll start some other topic in our next class. Means if it is tomorrow, I am not pretty sure that if the classes are there tomorrow or not because of election duty. So maybe holiday, but